The next section here is the future value. This is chapter 3, section 3. Future value of an annuity, and it's also called a sinking fund. Okay, so I kind of explained it a little bit earlier. So what is an annuity? Annuity actually is a sequence of the equal payment, okay, equal periodical payment in here. So for example, if you want to save for your college expense or for your retirement, right? When you first start working, like at age 15 or 16, when you start working, you can like save $50 a month, okay? And then when you save $50 a month for a few years, actually you are doing an annuity, all right? Because it's a sequence of the equal payment per month, okay? If the payment are made at the end of the each time interval, the annuity is called ordinary annuity, and that is our book. Our book only talk about the ordinary annuity. Okay, if the payment are made at the beginning of the each time interval, the annuity is called annuity due, and we don't. Our book is using the ordinary annuity, so the textbook only consider the most common type, which is the ordinary annuity. All right, because the formula do have a little bit different, but we only just talk one type. Okay, the total amount we call the future value of an annuity is the sum of all payments plus the interest you earn. Okay, so the future value for the annuity we're using the FB. For the present value or the principal we're using PV. All right, because the formula for the annuity is different. So this is the formula. I know it looks a little bit bigger, but the good news is we can use a calculator to calculate this one if you want to. Okay. The equal payment ordinary annuity future value is equal to the payment. PMT is the payment. Payment you pay every month or every year. Times 1 plus I to the n minus 1 over I. I is the rate per period, so I'm giving you a little bit formula. I is equal to R over M. Okay, N is the total number of the payment, or equal to NT. All right, so remember the payment is made at the end of each period. So look at this one right here. We want to find the future value of this ordinary annuity. If you deposit 2,000 at the end of each year into an account, earning the interest rate is 9% compound annually. All right, what is the value of the annuity at the end of the 20 years, and how much is the interest you earn? Okay, so we know that annuity is also a compound interest, but what's different of the annuity and our regular compound interest? This is a very key one, very important one. The compound interest we used earlier, even compound monthly, compound continuously, they are just only one-time deposit. You deposit one time and that's it, forget about it. You deposit one time for 5 years or 10 years, and you leave the money there all the time, keep growing. Okay, the annuity you deposit more than one time. You deposit every month. Like I said, you deposit every month for 5 years, and that is how many deposit? That's if you deposit every month for 5 years, that's 60 deposit. Okay, so when you have an equal payment, equal deposit every time for more than one time, it's called annuity. All right, our regular compound is only deposit one time, so that's the key difference. All right, annuity, like if you buy a car, you pay it every month to the dealer, car dealer, or to your bank. You actually purchase an annuity from the bank or from the car dealer because you pay every month equally. Okay, so that's the annuity. And same thing as the mortgage. You get a loan from the bank and then you pay the mortgage every month. So you actually buy annuity from the bank. All right, so that's the key difference in this case. So if we deposit 2,000 each year for 20 years, how much do I totally deposit? I can really calculate the amount of deposit, total amount of deposit. I have 2,000. Okay, I deposit each year, so that's one time a year for what? For 20 years. So I deposit, how much I totally deposit? That is 40,000. Okay, 2,000 a year for 20 years. So I totally deposit 40,000. That's my principal, right? My principal, my total principal is this much. All right, so assume your present value, you don't have anything to begin with, right? So you start depositing 2,000 for the first year. So your future value here will be payment is 2,000 times 1 plus I. Remember I, we need to using I here. I here is the rate per period. So since you only compound, you only make an annual deposit, so M is 1, so that's equal to 0.09. Okay, so I is equal to R because M is equal to 1. And then the N here is MT, so you have a 20 since actually I'm write down this one. So you have you deposit one time a year for 20 years, so that's 20, right? So we have I is 0.09 to the 20 power. Remember this is minus 1 divided by 0.09. All right. In order to calculate this one right here, if you put in a calculator, you might need another parenthesis in here for the numerator. Okay, so I want to go ahead and put this one in a calculator. All right, so let's go ahead and 2,000 times, remember I need a 2 parentheses, right? 1 plus 0.09 parentheses raised to the power of 20, okay, and minus 1 because this is minus 1, so this whole thing is my numerator. Oh, okay, and then divide by 0.09. All right, so you have a 10.02320.24. Okay, if you think this is too much, you don't, sometimes you got lost in here, you can calculate this inside the parentheses first. Look at this one right here. I can calculate 1 plus 0.09 to the power of 20, right? I can calculate this one first, and then minus 1, okay? And then minus 1, that way I don't have to have a parenthesis. And then I can divide it by 0.09, okay? You can calculate step by step, and then multiply by 2,000. All right, I got exactly the same answer right here, right? So you can kind of break it down if you think it's too much to input it at once. Okay, so you can break it down, calculate this parenthesis first, and then minus 1, and then divide by this one, and then entire thing multiply by this. So that's the future value. You have a $102,320.24. That is your future value. If you keep doing this every year for 20 years, you will have this much money. Okay, and how much is the interest earned? The interest earned here will be using the future value or the total amount minus the principal, right? You only deposit, you actually put this much money in. You only deposit this much, in your real money. But look at how much interest you earn already. Okay, so you have a 62320. All right, so you earn, look at that, you earn $62,000, more than $62,000 on the interest. All right, so that is called the future value of the annuity in here. Okay, the good news is I'm gonna show you how do you using an app in a calculator for this one, because when you have this kind of annuity, there's an app in a calculator, right? So let me go ahead and show you the app in here if you don't want to use the formula. Okay, go to app and then finance. Use the first one, TBM solver. You can use this one to calculate the annuity. Okay, only for the annuity. This N here is the total amount, so the total number of deposit times. So you have 1 times 20, so you deposit 20 times. The good news is this app interest rate, you will use the percentage, so that's 9%. You don't need to change it into decimal point because this app here giving you the percentage. Okay, present value, you don't have anything right now, and the deposit, you use the negative 2,000. Okay, future value, we're gonna clear that because we're gonna come back to find the future value. So you payment per year, you pay only 1 times a year, and you also compound 1 times a year. The payment using at the end is the ordinary annuity. The beginning is called annuity due, but our book is always using the ordinary, so leave that one at the end. And then we're gonna come back to solve this one. So you input everything in here. Second alpha enter is solved. Look at that, alpha enter is solved. Do I got the same answer? Yes, I got exactly the same answer. 102,320.24. Okay, so if you don't want to use the formula, there's an app in the calculator for the TI-83 or TI-84 for the annuity. Okay, so that makes it really convenience in here, and I do allow you to use the app for the assignment. Okay, any questions? All right, we're gonna look at another one is called a sinking funds. So what's a sinking funds? I explained it a little bit earlier, right? The amount that it takes for accumulating funds to meet future obligation or debt is called a sinking funds. So this is just a fancy name for the business, basically. All right. Like I said, if you want to buy a house, and you have to have a 20% down payment, right? Uh, 20% down payment for a house is a pretty significant amount, right? So it can be like a 20,000 or 50,000 deposit, depends on the value of your house. So you might have to, make a little bit of planning. So if you deposit every month into the bank to meet like a 50,000, in 5 years, that is called a sinking fund, right? Whatever that money you use it for. If you use it to paying the debt, usually it's for the government or company. Like I said, the building, you're gonna have to repair the building at the end of every 10 years, or you need a new equipment at the end of every 5 years. So you need to save those money, called future obligation, whatever the future obligation is, right? So that's called a sinking fund. Okay, for that purpose. So basically, the sinking fund here is you set up the future value. Like I said, the future value gonna be 50,000. So in order to accumulate 50,000 in 5 years, how much you have to deposit it now? Giving you the interest rate. Okay, so that is a fancy name called a sinking fund in here. So basically, we need to know we have to calculate the payment. So this formula is the same as this formula. Basically, it's the same as this formula. And if I, you know, divide both sides by the coefficient of this payment formula, I will solve this one. So basically, this formula and this formula is still the same. When we write down the payment, we just flip a numerator and denominator and giving you this formula. All right. If you don't want to use this one, you can still using the same formula and then just divide by the coefficient of the PMT at the end. It's the same thing. Okay. All right. So look at this one right here. Parents decide to set up a college fund for their newborn, and they want to have 100,000 in the account when the child reach age 18. Okay, they plan to deposit money once each year. Okay, so that's once each year on the child's birthday. The first deposit is made on the birthday at the end of the year one. So this is ordinary annuity. Okay, how much must they deposit into the account paying 6% interest rate compound annually, okay, to meet their goal. All right, so this is whatever paying down whatever the money you're gonna use, you're gonna have to raise 100,000, want to reach 100,000 at the age of 18. So n here will be 18, right? And then since you compound annually, so I here is 0.06. So I can put this one into the here future value. I need 100,000. Okay, and then I here is 0.06, and here is 18 minus 1. All right, so calculate this one right here. It seems like a lot. I can do this one in a calculator. Calculate this one. Okay, so we have 100,000 times 0.06. I can multiply this first, and then I'm gonna have to divide by the denominator. Remember, when you divide by the denominator, this entire denominator need another parenthesis. Okay, need a parenthesis in here. All right, so the parenthesis is so important in here. So the entire thing need a parenthesis, and then I have 1 plus 0.06 to the power of 18. Okay, and since this 18 is only 1, so minus 1. Oh, I forgot a parenthesis already. I need to have a parenthesis at the very beginning in here. So let's go back. 1 plus 0.06, which is okay. And then minus 1. And then I have another parenthesis. Okay, so that's 3235.65. All right, so that is how much you have to deposit each year in order to have 100,000 at the age of 18. Okay. The good news is, I said earlier, since this is annuity, so I can also use the app. So how do I use the app here? Instead of the formula, I go to app, finance, TBM solver, and here is 1 times 18 or just 18, right? And interest rate is 6%, okay? And my payment, which is unknown, so I'm gonna come back to solve this one right here. This time we know the future value has to be 100,000. Okay, so payment per year is compound annually, right? Yeah, it's compound annually, so that'll be just 1. And then we just come back to solve this payment in here. So alpha enter is solved, okay? And the payment, because it's out of the pocket, so it always using a negative number. So you're gonna pay 3235.65, exactly the same as the formula. Okay, so if you don't want to use the formula, there's an app for this one, which is make it a lot of easier. All right, I think there's growth in IRA, right? This is a very interesting question. I think I also have a little bit institutional learning outcome similar to this one. So that means you kind of want to know how to solve this one. So Jane deposit $2,000 each year into a Roth IRA. So the Roth IRA, that means earn tax-free interest, right? And the interest is earning a 6.85% compound annually, okay? Due to the change in employment, deposits are stopped after 10 years. The amount continues to earn interest until retirement 25 years after the last deposit was made. How much does Jane have in the account when she retires? Alright, so this one is kind of a little bit interesting in here. She only deposited into the Roth IRA for what? For 10 years, right? But after 10 years, she didn't touch that. So what happened in here? So this actually has two different type of interest. The first one from 0 to 10 years, and then from 10 years to 25 years. Okay, the first part actually is annuity. Alright, after 10 years, she didn't touch them, so this will be just a compound only. It's not an annuity anymore. So the last 15 minus 10, 25 minus 10 is 15. The last 15 years is just the regular compound. Alright, so we have to break down this one into two parts. The first part, this is the future value of this annuity. And the future value of the annuity become the principal for the second part, the compound. Alright, so how do we find the future value for the first 10 years, the annuity, which is we have a formula, or you can use the calculator app, right? So the deposit $2,000, and then 1 plus I here is 0.0685. Remember, if you use the formula, you have to change it into decimal point. And this is deposit is compound annually, okay, each year. So that's only one time a year. So that's 10, right? I here is 0.0685. Oh, this one has to be minus 10. Alright, so I am going to use the app to calculate this one, which is a little bit easier. Okay, so this first, she only deposited for 10 years, and the interest rate is 6.85. Present value, she doesn't have anything, okay? And then this annual deposit is 2,000. Alright, so since the compound annually, so everything is this one right here. Alright, so I want to find a future value. So everything is in, and then alpha enter, that's the future value. So future value is 27. Okay, future value is 27437.89. Alright, so after this one right here, what happened? After this 2747, after reach the 10 years, she doesn't deposit that anymore. So this becomes just the regular compound. So from 10 to 25 years, so second part. Okay, from 10 years to 25 years, so the T here is 15, which 25 minus 10 is 15. This is a regular compound. Regular compound. It's not an annuity anymore. So the regular compound, since it compound annually, so we're gonna using A equal to P times 1 plus R over M to the MT. That's the regular compound because we after this one last deposit at the end of 10 years, they don't deposit it anymore, so just let it grow for another 15 years. Okay, so this future value for the annuity become our principal here. So this is 27437.89 times 1 plus R. R here is 0.0685, M which is 1 annually. And then that's 1 times T here is 15. Okay, so that is the regular compound. So you can, this regular compound formula is much easier to calculate, right? So we can go ahead and calculate this one right here, not using the app because it's regular one. And then 1 plus this one will be just 1.0685. And then to the power of 15. Alright, so she's gonna have a 74125. 74125.67. Alright, so look at this one right here. If she deposit like 2,000 a year for 10 years, and then let it compound, continue compound, but not deposit anymore after 10 years, she's gonna have this much money at the end of the 25 years when she retire. Okay, so how much does it have in the account? That's this much. How much did the interest earn for this 25 years? Well, the 25 years interest earned, you will have let's see, future value of the compound after 10 years deposit, yes, so we have this much the future value, right? And then let me just go ahead and double check the number. Okay, so that's 27437.89 times 1.0685 to the powers of 15, so that's right, 74125.67, right? And then if you want to see how much interest in total earning using this one minus the deposit, okay, minus the deposit in here. So how much is the deposit? Oh, she only deposit 2,000 a year for 10 years, so that's 20,000. 20,000 from here. So that's how much interest she earned in here. So you can see there's a lot of interest in here. Okay, that's how bank make money as well, right? You go to get a car loan, mortgage loan. That's how they make interest. Okay, another one here is okay, another concept here is called amortization. All right, I know it's gonna be a lot of concept in this chapter. Okay, so what is the amortization in here? Amortization is kind of all right, there's another example about an annuity here. Okay, so approximate interest rate. Okay, so we're gonna use the calculator for this because the formula will be getting really long. A person make a monthly deposit $150 into an annuity, ordinary annuity. After 30 years, the annuity is worth $500,000, right? $250,000. So what is the annual rate compound monthly has this annuity earned during the 30 years period? Okay. So remember we know the payment here. We have a PMT, payment is $150, right? T here is 30. M here, since deposit monthly, so M here is 12, okay? And then the total deposit time, you deposit 12 times 30 years. So you totally deposit, what, 360 times, because you monthly for 30 years, all right? And the annuity was, so that means this is a future value. Okay, we want to find the interest rate. So if you go to use the formula here, I'll copy down this formula. So that means we want to find the I in here. We need to find the I, right? We have a future value, we have a future value, we have a payment, we have an N here. So we all know, but we need to find the I inside here. All right, you want to find the I here, which is gonna be a little bit tricky in this one. That's why I suggested using a calculator will be much easier to solve this one. So I'm gonna show you how to use a calculator in here. Go to the apps, finance, TBM solver, and here is 12 times 30, which is 360, right? And the interest rate is the one we want to find. So this we're gonna put it 0 for now. Come back to solve this one. The present value is 0, which is right because we don't have anything to begin with. And then the payment here is 150, so we use the negative 150 in the app. Always use negative for the payment. Future value will be 250,000. Okay. And the payment, this is compound monthly, so payment per year is 12. Compound also monthly, and then payment is at the end, so that's right. So I can just come back here to solve the I. Look at that, this is how easy using the app. So alpha, enter is solve, so that's I. Okay, so my I here is 8 point, if you want to 2 decimal places, is 8.55. So I here is about 8.55%. Okay, so very, very easy. You can use this app to solve any one of these. Okay, any one of these in here, and it's much easier. All right. Okay, last section for the chapter.